Hello, I decided to record several videos on Python libraries which you can use to analyze your molecular dynamics trajectory as an alternative to traditional tools provided with simulation packages like Gromax. This particular video is the first video in a series of videos dedicated to the MDAnalysis library. Here I give you a brief introduction of what you can do with this library, and later in this video we cover the process of setting up a conda environment with all the required additional libraries besides MDAnalysis, so you can start using them for molecular dynamics trajectory analysis. MDAnalysis is an open source library which provides you with a diverse set of tools to manipulate your molecular dynamics trajectories and topologies and to analyze them using different methods. MDAnalysis allows you to process topological and trajectory files of different formats. It is not only limited to Gromax file formats, but is also compatible with other packages for molecular dynamics simulations and molecular mechanics. Also, this library gives you more flexibility in setting up your own workflow of trajectory analysis as compared to traditional tools, for example, of Gromax package, which are already compiled and rigid. You can only modify them by passing different arguments. Of course, it also has its drawbacks. For example, it is not always compatible with newest versions of trajectories and topologies when they are released, but since they usually sold within days after the release. Also, for certain types of analysis, MDAnalysis performs slower than some compiled tool like tools of Gromax package, but overall it is really versatile and can be applied in a number of cases. Initially, we need to create the conda environment. We use here Python 3.11 instead of the latest Python version to ensure compatibility with all the packages that we are going to install in this environment. Here I use Fedora OS, but it will also work on VSL too. Now it's time to activate our newly created environment, and conda tells us exactly how to do it. Now we can fill our environment with different useful packages. We will download them from conda Forge repository, and conda will ensure that they are compatible with each other and there are no dependency conflict. Well, in most cases this should work just like that. That's what the conda is for. I specifically created separate environment instead of installing everything system-wide, just to avoid possible bleeding of packages with different versions into other projects. This is a common practice, and it is really preferable than keeping everything in one pile. If you feel like conda is solving your environment too slow, you can try Mamba, which is like conda on steroids, and it will do the job faster. But in this case, I do not resolve anything huge like Amber tools, so I use conda to avoid possible confusion with the names of the tools. Let's start our local Jupyter Lab server and check out if everything was installed correctly. For those who don't know, Jupyter Lab is commonly used in all sorts of Python projects. You can use it to test stuff, to run actual calculations. It allows you to dynamically check certain code samples in a Jupyter notebook. And you can quickly work things out quicker than you would do if you use, normal text editor and run it from the interpreter. It starts in your browser, you create a new notebook and select the proper kernel, Python kernel, to perform calculations. I will call this particular notebook MDAnalysis Tutorial 0 notebook. We will first import MDAnalysis library and test topology and trajectory files from MDAnalysis test package. Then we will create the universe instance and check the number of atoms, frames in it. Then we click Run button and the code is being executed. A new code snippet is being created, but we don't need it in this particular case. As you can see, we have output with the number of atoms in our topology file, the number of frames in our trajectory, and we also got a warning that certain features are considered deprecated and will be removed. And you can shut up those warnings, as I will show you how to do it. This way we will only receive warnings which are relevant for us right now. Last but not least, let's check the matplotlib by plotting a linear function of our indexes and frames in trajectory. Matplotlib is a versatile and de facto standard Python plotting library which you can use for all sorts of visualizations of scientific data, including the data obtained as a result of molecular dynamics trajectory analysis. It also has various extensions if for some reason you find the set of tools provided by the standard matplotlib limited. There is also Seaborn, for example, for dot plots. And it is generally useful to know how to use this library, not only for molecular dynamics simulations, but for doing statistics, for example. Matplotlib provides with different interfaces for plotting. I here use the fastest one through pyplot, but if you need to configure complex features with different subplots and axes, then you will have to use different API. And yes, matplotlib was installed correctly, and we can clearly see that it is capable of plotting stuff. That's it for today. To turn off your Jupyter Lab server, just press Ctrl and C in your console.